are going to learn about the distance problem. And I'm not sure if you guys are aware, but this is the link. When you guys are dealing with a distance problem, there's a specific pyramid that you guys can use. And I'm pretty sure you guys have seen something similar at least once. So this, at the top of the pyramid, we're going to have distance, and we're going to have speed, and we're going to have time. As long as you guys remember this relationship, you guys will never forget about and to solve the distance problem. It's going to be quite simple. So how do you use this pyramid? If I want to find distance, you circle that letter. All you have to do is to look for the other two letters. The distance is going to equal to speed times it by time. If I want to find speed, you circle speed, and then you see the horizontal line over here? That's a fraction. It will be distance over time. And if I want to find time, it's going to act very similar to speed. Time will equal to distance in the horizontal line over speed. Yep, this is the only three things that you guys have to remember for this lesson. Oh, okay, so as long as you guys remember this relationship, you guys will never get it wrong. So instead of memorizing these three equations, I want you guys to memorize this pyramid. It's easier to, in that way you don't have to memorize these ones, the three equations at the bottom. You guys can just draw that pyramid, and then you can just develop your own equation. Okay? So that's something that I use all the time when I was a student. And it works really well. And it will work for these questions. Okay, now, as I said, for those who have submitted your homework, could you please press A? And now I'm going to leave it open like that for a moment. Okay. All right. Now take a look at this question, guys. If two objects start from two different places traveling opposite directions along the same road, they are bound to meet on the way after some time. And we need to use distance, speed, and time to solve such problems. So these problems are called distance problems. And please note the length of the two objects themselves are not considered in this lesson. So we're just going to assume that yellow car is over here and the blue car is in this location at the moment. And we want to see when and when are they going to encounter each other? That's the sort of question that we want to find today. Okay, so as you guys can see, these are the three relationships that you guys are going to use today. But as I said, just remember just to use this pyramid when you guys are doing this question. Okay? All right. Now here's a quick warm-up question, guys. The two places are 200 kilometers away from each other. Two cars A and B drive at the same time from the two places opposite each other along the same road. Car A's speed is 60 kilometers per hour and car B's speed is 80 kilometers per hour. After how long can the two cars meet? Okay, in order to solve these questions, it's best to draw a diagram. So if this is my and this is A and B, and they're driving towards each other at the same time. So if it's been 1 hour, it's been 1 hour for A and it's been 1 hour for B as well. And we know the total distance is 200 kilometers, they're 280 kilometers apart. And A is traveling at 60 kilometers per hour, and B is traveling at 80 kilometers per hour. So this is a cool trick that you guys can use. When you guys get a question like this, what's going to happen after 1 hour? For A, after 1 hour, he A traveled 60 kilometers, right? And B traveled 80 kilometers in the left direction. So what's going to happen to our distance? It'll get shorter and shorter, right? The distance between each other are going to get shorter and shorter and shorter. So what you guys have to do, that is same as saying, if I add, because time is going to flow equally to both of them. So 60 plus 80, the combined speed times it by time, which is something that we want to solve right now, is going to equal to 280 kilometers. And that's the distance. Yes, it'll be 140 t equals to 280, and 2 will be 280 divided by 140, and that's going to equal to 2 hours. And when you guys, just be careful with the units. You always have to look at the unit when you guys are dealing with this question. Yep, so it's going to be A. Now, over here, what I've used is that if this is my pyramid, I use the top one. Distance is going to equal to speed times it by time. And in this case, for a question like this, your speed is always going to be a combined speed, because the distance is going to get reduced all the time. Okay, that's the trick that you guys have to use. That's the only thing that we're using for the first half of the lesson. So guys, please make sure you guys use this method. Okay, any questions so far? All good? Oh, Lucas, you need help? Yes, Mia, you okay? Oh, okay. So Lucas, you have to know that they're starting at the same time. They're starting at the same time, and the time will flow equally to both of them. If A travel for 2 hours, B travel for 2 hours as well. And after that, all you have to know is that, all right. Okay, all right, cool. Now, in that case, let's move on. So here's a summary. With the above explanation, we can obtain the equation for the distance problem. Traveling in opposite directions. This, well, I don't want you guys to use the formulas for this. I just want you guys to think about that relationship, and it's going to work. The time travel will equal to the distance between those two objects and divided by the total speed. By transforming the above expression, we can also change the following two equation. The total speed is going to equal to the distance traveled divided by the time traveled. So once again, just use your pyramid. Time would equal to distance over speed. So that is correct. And your distance would be just time, speed times by the time. As simple as that. Okay, as seen above, we can use an equation to help us sort out the conditions so that we can find the answer faster. So let's try this one. Two cars A and B drive opposite each other at the same time from two places, 662 kilometers apart. And they encounter each other 8 hours later. And it is known that B travels at 42 kilometers per hour, but how many kilometers per hour does A travel? So in this case, we're not too sure about the speed. So we're looking for speed, kilometers per hour. That's asking us the speed of A. Okay, so but we know the distance between each other, and we know the time. So in our pyramid right now, we know distance, we know time. We don't know the combined time. So if I want to find the speed, what should you do? Speed is going to equal to distance over time, right? And your distance is going to be 632 kilometers, and the time took 8 hours. but your speed is not just speed, it's a combined speed. It'll be let's just say x for a, the speed of a, and then plus 42 kilometers would equal to 632 over 8. Okay, now what's 632 divided by 8? That's 79. And all you have to do is just algebra, right? Just x 72 minus 42, sorry, 79 minus 42, that's going to equal to 37 kilometers per hour. And that's why C is the correct answer here. That's how you do it. Can you see how I just used this definition using my pyramid? That's what you guys have to do. Look for the information that you already know. Just put it in your relationship. Easy. Very good, guys. Very good. And thank you for those who have pressed A. Here's a trophy, guys, for those who have submitted their homework. Wait. So I'll try that again at the end because we still have students who didn't come in just yet. I'll do that at the end. Okay. So this is going to be your turn, guys. A car and a bicycle travel opposite each other from two places 172.5 kilometers apart at the same time. And the two vehicles meet 3 hours later. It is known that the car traveled at 44.5 kilometers per hour. How many kilometers per hour did the bicycle travel? Okay. Now, I'm going to give you guys 3 minutes to work on this question. It'll be good if you guys can draw the image over here. Okay, and you guys can submit your answers whenever you guys are ready. Please use our relationship. Just use a pyramid. We know the distance between each others. We know this. We know time. That we know the combined speed. Oh yes, Jake. I'll put you on stage. I'll let you come up on stage first. Okay. So guys, just be very careful with your calculations. Since we have a decimal, we might make a mistake. So please double check with your values. Jasper, Paylin, Catherine, Lucas, could you guys please double check? Mia, could you please double check? Ting, Eric, Yilin, Benji, could you please double check? There we go, Yilin. Very good. All right. Yeah, I think it's the decimals that confuse you guys. Very good, Eva. Yes, Catherine. There we go. Okay, I'll let Jay come up on stage first. And Victor, you can come up on stage next. Hi, Jake.
Now, can you move the selector? So we know that a car and a bicycle. I didn't draw that really good. So a car and a bicycle travel. A car and a bicycle travel opposite each other from two places. 172.5 km apart at the same time, and two vehicles meet 3 hours later. It is known that the car travels 44.5 km per hour. So how many kilometers per hour does a bicycle travel? So we know that D equals T times S, and so the distance is 172.5 km. And the time is 3 hours later. So to find the value of the speed, the altogether speed, you have to do. I'm just gonna erase it. Because there's no mistake. So then we do 172.5 km, which is the distance divided by the time, which is 3, and then we get 57.5, which is the speed for the car and the bicycle all together. So we know that the car travels 44.5 km an hour. So then we do that minus that, which is 13 kilometers.
There we go. Very good, Jake. Very good. And hello to your sister. Well done, Jake. Very good. Well done. Well done. Yes, there we go. And well done for those who got D for the answer. Well done, guys. Yes, you're absolutely correct. The correct answer is going to be 13. So it really doesn't matter which one, which relationship you use. But you just want to, since we're looking for the combined speed, you can just do this. Distance over time, and speed will be 44.5 plus the speed of the bicycle would equal to the distance apart from each other and 3. And that'd be 57.5. And if you want to solve for B, you just have to subtract that by 44.5, which is 13, sorry. And of course, your unit is going to be 13 kilometers per hour. Good, great, guys. Let's move on to the next question. Whoa. Okay, now two objects traveling opposite directions along the same road will definitely meet after some time, but we can also discuss the distance between them before they meet. Check this out. Two cars A and B drive towards each other at the same time from two places 654 kilometers apart along the same route. Car A travels at 37 kilometers per hour, while car B travels at 42 kilometers per hour. After 8 hours, how many kilometers are the two cars still apart? Okay. So this is a diagram that we have here. A is here and B is in this location, and they are 654 kilometers apart. Okay. Now, if A is traveling at 37 kilometers per hour and B is traveling at 42 kilometers per hour, we want to know how much they traveled after the 8 hours, and all you have to do is to subtract that from your total distance. So let's find out the distance traveled. So once again, the distance, we have speed, we have the combined speed, we have time. So we want to find the distance. In this case, that'll be speed will be the combined speed, and you have to multiply that by 8 hours. So what's 37 plus 42, guys? That's 9. That's 79 times up by 8. And that's going to be 632. So that's how much they traveled after 8 hours. And all you have to do is to subtract this value from this one. And that will tell me the gap between them. Okay, so that'll be the gap would equal to 654 minus 632, and that's going to equal to 22 kilometers. There we go. So that's how you do it. Once again, since we are looking for their distance traveled, all you have to do is use this relationship, find your unknown value, apply that to your question. And that's why B is the correct answer. Now, how do you feel about this question, guys? Are you guys good? It's just the same repetition. Easy. Very good, Victor. Excellent. Very good, Emma. Okay. Very good. Oh, yeah, not this question, Jake. Not this one. Ask is usually mine. Okay, now, you guys are going to try this question. Let's see how we go. Two cars A and B travel towards each other at the same time from two places 800 kilometers apart and along the same route. Car A travels at 45 kilometers per hour and car B travels at 65 kilometers per hour. Now, how many kilometers apart are they still after 6 hours? Now, here's your options. I'm going to give you guys 3 minutes once again. Please try this question. And the selected tool is on, and you guys can submit it whenever you guys are ready. And you guys don't have to draw the diagrams. I will draw it for you. If this is car A, this is car B. Yes, Lucas, I'll let you come up on stage. And then we can have Victor next. And then Mia. Okay, I'll write this down. Okay, very good. Wow, that is so good, guys. I can see everyone is getting correct so far. If both of them travel for 6 hours, what is the gap between each other? Jake, Lee, could you please double check? I think that's a calculation error over there. Yes, Mia, you okay? Mia. You're right, Mia. You can chat to me. Oh, Paylene, could you please double check? Eric, could you please double check? We still got a minute. Jess, could you please double check? Times 6? That's correct, Mia. Very good. You do have to times it by 6. And just remember, you can multiply 6 individually. Or why don't you just combine them and multiply by 6 in one go? There we go, Palin. Very good, Pollyanna. Very good. Very good, girls. Very good. Well done, Cindy. Okay, now, Lucas, this is your turn. Victor, you're next.
Ooh. So what you have to do is like, because we know that like car A travels at 45 kilometers per. Since we know that car A travels at 45 kilometers per hour, then in that car B travels at 65 kilometers per hour. All we have to do is add 45 kilometers with 65 kilometers, which equals to 110. 110 plus times 6 hours is going to be 660, and then 800 kilometers subtracted by 660 kilometers is 140 kilometers, which is C.
Very good. Exactly. Very good, Lucas. That is perfect. Well done, buddy. That's how you do it. Well done, guys. Thank you so much, Lucas. You did it in 1 second. That is pretty good. And Aiden, wow. Victor, Catherine. And who's this student? I can't see the name. But Eric, wow. Sophie, a lot of you have submitted your answer in less than 10 seconds. That is impressive, guys. That's very good. Well done. 32 of you got it correct. Well done. Excellent, guys. So, you guys, when you guys are multiplying this, well, if you're not feeling confident, you guys can do it this way. Multiply 6 individually. But can you see how the multiplication of 6 is a common multiple? So that's why I just took the 6 out and then combined it like this to do it in one go. Yes, Mia? You can still chat to me. Hi, Mia.
So for the 45 times 6 plus 65 times 6, and it's also in the second one, you forgot the times.
Yep, so you see that bracket? If there's a number outside, there's an invincible multiplication. Okay?
Okay.
All right. Okay, thank you, Mia. Yep, if you have questions, just let me know. All right. So that's how you do it. And well done, guys. Yes. Once again, we want to look for the distance traveled for both of those two objects. So that would be distance equal to speed times by the time. The combined speed is this one over here. That's the relationship. And I'll just put a multiplication sign just in case. And that's going to equal to 110 equal to our distance, which is, so they've traveled a total of 660 kilometers. And all you have to do is to subtract your total distance apart from each other, and they just got 140 kilometers left. Okay, and that is why C is the correct answer there. Now, two stations are 470 kilometers apart from each other. Car A leaves station A at 1 p.m. and travels at 52 kilometers per hour. Another car leaves station B at 2:30 p.m. travels at 60 kilometers per hour along the same road. How long will it take for the two cars to meet? Okay, guys, so this question is a little bit different. So A had a head start. B's here, and A used to be there, but now, since he traveled for how many hours did he travel earlier? His A started at 1 p.m., B started at 2:30 p.m. So it's been 1.5 hours, right? So A's at this location at the moment. So let's find this distance. So and A still, and this combined distance over here will be 470 kilometers apart. Okay, so, and B is traveling at 60 kilometers per hour, and A is traveling at 52 kilometers per hour. And all you have to do is find the distance traveled by A for 1.5 half hours. So 52 times it by 1.5 hours. And what's 52 times it by 1.5? It's going to be 78 kilometers. So by the time B started his journey, A has already traveled 78 kilometers. So what we are interested in is the remaining distance between each other. So that would be 470 minus 78, and that's going to equal to 392 kilometers. And that's the distance that you guys are going to use here. Okay, so let's start. So it's just the same after that, just one extra step before our regular steps. So all we have to do, since we're looking for the time, how long would it take? So we want to look for the time. Okay, so time is going to equal to the distance remaining divided by the combined speed. So that'll be distance is 392 kilometers divided by 52 plus 60. There we go. So that's 392. Let's simplify this. That's 112. If you simplify all that, you guys are going to get a value of 3.5 hours. There we go, and that's why A is the correct answer here. Now, let me see if you guys are okay. Let me just quickly check. Could you please press A if you're good? Press B if you need a little help here. Okay, looks like you guys are okay. Very good. Yes, Jasper? Oh, I can't press you. There we go, I found you. How can I help you, Jasper? Oh, that's Emma. Sorry. Emma, don't worry. Emma, how can I help you?
So how did you get the 78 kilometers?
78? Okay, so how did I get 78? Because if you look at the time, car A started at 1 p.m. He started his journey at 1 p.m. On the other hand, B started his journey at 2:30 p.m. So A's been traveling for 1.5 hours, right? It's been 1.5 hours. So you'll have to find A's current location. And after 2:30, once the clock reaches 2:30, they'll be traveling to each other, and the time will flow equally to each other. So what you have to do is to find the distance traveled by A for 1.5 hours. And you'll have to figure out the distance remaining between each other. So when B started his journey, A has already traveled 78 kilometers. You just have to multiply, since we're looking for the distance traveled by A, distance equals the speed times it by time. Speed of A is 52, the time traveled by A is 1.5 hours. 1.5 times it by 52 equals to 78. There we go, that's how you do it. And after that, just subtract that value from 470 and you'll get the remaining distance between A and B. Is that okay, Emma? Is that better?
Yeah, okay, thank you.
Alright, Emma, very good. And Jasper, do you have the same question? Yes, Jasper, you're on stage. You okay? I'll open up the chat for you, just in case. You good? Okay. Alright, so let me help you out. So, the distance between the two stations is 470 kilometers. Car A left the station at 1 p.m. and he's traveling at 52 kilometers per hour. Another car, let's just say from station B, he started his journey at 2:30 p.m. and is traveling at 60 kilometers per hour. How long would it take for the two cars to meet? So, A's been traveling since he left. He had a head start, and he traveled for 1.5 hours by the time B started his journey. So, since A's been traveling before B, can you see how the distance between each other has gotten shorter? The red line shows me that the distance between A and B is now 392 kilometers. Why? Because A's been traveling for 1.5 hours before, and he traveled 78 kilometers by the time B started his journey. And after that, after this step, once you found this remaining distance between each other, it's just the same step after that. This is what we've been doing so far. Time, we're looking for the time. When are they going to meet? So you just have to do the time when they're going to encounter would equal to the remaining distance over the combined speed. Because time is going to flow equally to each other, so you can simply just combine those speed together. And that'll be 392 divided by 112. So in 3.5 hours, 3.5 hours, they are going to encounter each other. Okay? Is that better? Alright, Jasper, very good. Let's try the next question. Very good, guys. Excellent. Very good. Okay, now this is going to be your turn, guys. Two cars are 680 kilometers apart. Car A drives towards car B first at a speed of 60 kilometers per hour. 2 hours later, car B drives towards car A at a speed of 80 kilometers per hour along the same road. How long would it take for the two cars to meet? So guys, it's just exactly the same as what I've done. One of them had a head start, and all you have to do is to find the remaining distance. And that's the value of the distance that you have to use. Okay, so let's try that. Very good, Kenny. Aiden, too good. Very good, Emily. Eric, yes. Victor, very good. And Victor, you're going to come up next. Very good, Mia. There we go. Excellent. Excellent. A, B. They are 600. Sorry, let's move that down a little. 680 kilometers apart. A is traveling at 80 kilometers per hour. Oh, you know what? Jess, Christina, Shelly, Lee, could you please double check? Very good, Daniel. Very good, Emma, Sophie, Jake, very good. Kevin, Ludi, very good. Yilin, Pollyanna, that's very good. Very good, Eric, Michelle, that's very good, yes. There we go. And who is this student? Can't see the name. Oh, that's Quincy, right. Well done, Quincy. Very good, Benji. Ethan, there we go, Shelly. Very good. So car A had a head start, right? What is this distance? How much did A travel in 2 hours? And what is the remaining distance? That's what you guys have to find out. Now let me take a look. Alex, Eva, Catherine, Palin, Kingsley, could you guys please double check? Very good, Jasper, you got it. There we go, Heather, Cindy, Christina, very good. There we go, Palin, Alex, very good. Yes, Eva, very good. Oh, that's time. Okay, very good, Jess, excellent. Victor, you're gonna come up on stage this time, and could you please help me out?
Okay. So because the two cars, car B starts, so this is the distance, total distance 680 km. So car B has a 2-hour head start. So because car B goes at 60 kilometers per hour, the actual distance, if they start at the same time, would have been 680 minus 60 times 2, because the 2 comes from the 2 hours later. So there'll be 680 minus 120. So that would be 680 minus 120 would be equal to 560 km. And then after that, we're looking for how long it takes for the cars to meet up. So it would be the time is equal to distance divided by speed.
Very good.
Yeah, the remaining distance divided by the speed. So that would be the distance would be 560.
Good.
So time is equal to 560 divided by the speed, the total speed, which would be 80 plus 60, which would be time is equal to 560 over 140, and then that would be 4.
Perfect.
So it would be 4 hours.
Very good, Victor. And just well, it's still correct, but it's the car A who had a head start. But it doesn't matter, since you used the correct units. It was car A is driving towards car B first. But it doesn't matter because you used the correct values, so that's good. If you have used 80, then that would have been wrong, but since you have used 60, doesn't matter. Well done, Victor, but that is great. Thank you for using that relationship, I can see that you can visualize the pyramid in your mind. That is great. Very good, Victor, very good. Excellent, buddy. Excellent. So there we go, guys. So well done. 34 of you got the correct answer. That is great. Please keep it up. Okay, guys, we're going to have a short break.